Welcome back. This is Professor Ridge, and today's lesson is on section 2.5, Variations and Applications. Direct variation. If a situation gives rise to a linear function y equals kx, or f of x equals kx, or y equals kx, we say that we have a direct variation. Also, we can say that y varies directly as x. That's another way to say the same thing. Or that y is directly proportional to x. Okay, so y, if we said any of these ways, y varies directly as x, that translates to y equals kx. So you immediately write that down. You can also say directly proportional. And sometimes you drop the word directly and just say y is proportional to x. The number k is called the variation constant, or the constant of proportionality. Okay, so k is your variation constant, or constant of proportionality. Okay, let's look at an example. Y varies directly as x, and y equals 20 when x equals 5. Find y when x equals 10. So whenever you read this, y varies directly as x, immediately you write down the base equation y equals, or the equation of variation y equals kx. Sorry about that. So y equals kx. Y varies directly as x translates to y equals kx. Now, all these problems generally have two parts. First, you're going to you're going to be given an observed value of x and y together. So y is 20 when x is 5. So our first part is you're going to solve for k. Find the constant of variation. Or you can say variation constant or constant of variation, same thing. So divide both sides by 5. So k is 4. Now once you know what k is, you can have the specific equation of variation, which is y equals 4x for whatever this situation is being described. And then now I can do part 2, which is find y when x equals 10. So you just plug 10 in for x, and you get y equals 40. So y equals 40 when x equals 10. Alright, so generally they always boil down to those two steps. First you got to figure out what k is, so then you can write the equation. Once you know the equation, you can now answer a whole bunch of questions, right? Y equals what if x equals, and then you're given a number. Or if y equals 17, what's x? So you can figure that out. Alright, let's try another one. Okay, so the amount of sales tax paid on a product is directly proportional to its purchase price. In Indiana, the sales tax on a Sony reader that sells for $260 is $17.50. What is the sales tax on an ebook that sells for $21? Okay, so again, the idea, I like to kind of throw out the extra words here. So sales tax is directly proportional to the purchase price. So sales tax is directly proportional to purchase price. So we'll use S for sales, or no, we'll use T for tax. Is directly proportional to the purchase price. Okay. So T is our tax, and P is our price, purchase price. Alright, so we know that the sales tax is $17.50. So again, there's two parts. You got to figure out k first. So k in this case would actually be your sales tax rate, but we don't have to think. We can think of it in terms of a direct proportion problem. So $17.50 equals k times the purchase price, which is $260. So we're going to solve it for k. Divide by $260. So So K equals, and then we just do 1750 divided by 260 is 0.0673. Now part 2, now we can answer the question, what's the tax if K is 0.0673, what's the tax, oops, that's P, what's the tax paid if we buy an item that sells for $21? So 0.0673 times 21 is $1.41 if we round it. And there we go. So we're going to pay $1.41 in tax on that $21 purchase. If a situation gives rise to a function f of x equals k over x, or y equals k over x, so again remember f of x just y, where k is a positive constant, we say that we have inverse variation. So this is inverse variation. And so the way we're going to translate y varies inversely as x is we're going to write the equation y equals k over x. And another way to say the same thing is y is inversely proportional to x. These are all the key words for inverse variation. And then just like before, k is still the constant of variation or the constant of proportionality. So I'm not going to write that down. Okay, so it's the same terminology there. Okay, let's look at y varies inversely as x, and y equals 12 when x equals 5. Find y when x equals 20. So again, just like with direct variation, inverse variation, same idea. You're going to start out with your equation, variation, y equals k over x, and then you're going to be, typically you need a x and a y, an observed value, to figure out what k is. So if y is 12 when x is 5, then you solve this equation. So 60 equals k. And now we can write the equation of variation with their specific k value. Y equals 60 over x. And then we can answer the question, what's y when x is 20? So you just plug in 20 for x, and you see y equals 3. So pretty straightforward. The weight that a horizontal beam can support varies inversely as the length L of the beam. Now we're assuming of a certain thickness, right? So, we're not comparing. Typically when you get a longer beam, you get thicker wood. But anyway, suppose an 8-foot beam can support 1,000 pounds. How many pounds can a 10-foot beam support? So we're assuming, the same dimensions other than length, the same width and depth. So again, I'm going to throw out my extra words. The weight, and we're going to make that W, I think. The weight W, that's what should have been there. So the weight varies inversely as L. So weight varies inversely, so K over L. Now again, the two steps, we're going to put in the weight. We support 1,000 pounds with an 8-foot beam. So we're going to multiply both sides by 8. So basically K is going to be 8,000 for this thickness of beam. So K, plug in K, 8,000. And now we want to know, if we had a 10-foot beam, how much weight can we support with 10 feet? So you just plug that in, and it looks like 800 pounds. So again, pretty straightforward. So all these variation problems, you basically going to cover those two steps. First, take your observed value to figure out what your k is, plug the k in, get the equation of variation, and then you solve it for the question they're asking. Y varies jointly as x and z. That translates to y equals k x z. So it's kind of like direct variation, but you have an extra variable. So y varies jointly as x and z. You just translate it to y equals kxz, and you go through the same process. You have to get observed values for x, z, and y all together to figure out what k is, and then you can answer any subsequent questions. If you're given two variables, you can figure out the third. Okay, so find an equation of variation for the given situation. So I just want to go over some different scenarios, just the first part of these type, just setting it up, finding k to get the equation of variation. Alright, so y varies jointly as x and z, so we translate that to be y equals kxz. Then we're going to plug in the observed value of x, y, and z all together. So let's see, y is 56, when x is 7, and z is 4. So that's 28k divided by 28. K is 2. And then once you have k, you can write the equation of variation with that specific k value. So y equals 2xz. Now we can also do combined variations, where you can say something varies directly as x and inversely as z. You can do it with powers. So let's do a few of these examples. Okay, so y varies inversely as the square of x would be y equals, inversely is, remember, k over x. But this is not inversely as x, it's inversely as the square of x. So it's y equals k over x squared. Then we plug in our numbers, our observed values. So we get 6 equals k over 9. So k is times both sides by 9. So k is 54. So our equation of variation is y equals 54 over x squared. Let's try another one. Alright, so this one looks kind of complicated. Y varies jointly as x and z, and inversely as the product of w and p. So I can even put a phrase in there. So I got y equals jointly as kxz, and inversely, remember inversely is over, the product of w and p. Alright, so now I'm going to plug in all my observed values. So y is 3/28 when x is 3, z is 10, w is 7, p is 8. So this is going to get me 3/28. It's going to be 30. Let's see if I can reduce this. That'll be 4. That'll be 5. So it'll be 15 over 28. And then multiply both sides by the reciprocal. 28 over 15. 28 over 15. So that's 1/5. So now I can write my equation. Y equals 1/5. I'm going to simplify, and 1/5 on the top. When I simplify it, basically the 5 is going to go to the bottom. So it's going to be x z over 5wp. Here, let me show you over. I don't want to waste another page, so let me just show you that over here. So if I think of it as k, so anything on top is multiplying, so I can pull that k out in front. if that's 1/5, I write it that way, and you can see that the 1 would go 1 times xz is just xz, and then 5wp would be on the bottom. Alright? So that's how I simplified that. Okay, so that concludes the lesson for 2.5. Go to My Math Lab, complete your exercises there, and I'll see you next time.